Hello, and welcome to Lesson 2 of C.1, the Polar Ice Unit. I'm Meijin Chia, a high school teacher using OpenSciEd and an OpenSciEd facilitator. In this video, I will give an overview of Lesson 2 and wrap up with some tips and tricks. Now, Lesson 2 is really important because students start to make connections between changes in sea level and global temperature and why global temperatures change, using evidence from articles and data. My students found it pretty challenging to synthesize all the evidence, so stay tuned for strategies to help students with sense making. First, let's recap on how we got to Lesson 2. At the end of Lesson 1, we conclude that many communities globally are affected by sea level rise. This motivates us to figure out ways to slow sea level rise. But first, we have to understand what causes sea level rise. We think sea level rise is caused by climate change, but we are not sure exactly how. Let's take a look at this lesson at a high level. Lesson 2 takes 3 45-minute days. It involves hands-on investigation using data sets, videos, and readings. So the 35 minutes of material preparation listed here is basically to prepare the data sets and readings. Students do not need to use their individual devices unless you would like them to explore the readings and or data sets using digital copies or play the NASA student videos on their own. These NASA videos are regarding changes to polar ice over the recent decades. There are 3 lesson chunks over the course of the 3 days of lessons, and these lesson chunks do not exactly align with the lesson days. The key symbol are some critical parts of the lesson that I will describe in more detail shortly. The first lesson chunk is explored on day 1. Students analyze historical data and read about different data collection methods. In this lesson chunk, students figure out that historical data show a correlation between global temperature, ice volume, and sea level. The second lesson chunk spans across 2 days. Students look at data from the same 3 readings in day 2 and day 3, but use different cross-cutting concept lenses. They figure out that while there are multiple possible causes or factors for changes in global temperature, recent increases in global temperatures is most likely caused by an increase in atmospheric carbon dioxide concentration due to human activity. The last 20 minutes of day 3 covers the third lesson chunk, where students figure out that global temperature changes when matter changes the flow of energy into or out of Earth's system, but they are not exactly sure how. So in lesson 3, we start thinking about how carbon dioxide traps heat in the atmosphere. So in summary, on day 1 of lesson 2, students conclude that in the last million years, as global temperature increased, ice volume would decrease while sea levels would increase. Then on day 2, students discover that global temperature is affected by Earth's orbit and tilt, volcanic activity, solar activity, and atmospheric carbon dioxide concentration. Finally, on day 3, students argue that the most likely cause of recent rapid increases in global temperature is atmospheric carbon dioxide concentration because this variable is changing at the right time and in the right direction and rate. Let's take a look at the key moments in lesson 2. One of the things we wondered at the end of lesson 1 is whether people have been affected by sea level rise before. So we analyze data from a million years ago. We see these cyclic patterns where there's a positive correlation between global temperature and sea level rise in orange, and a negative correlation between volume of ice in gray and sea level, again in the orange. And it's a cyclic pattern because we see that, for example, global temperatures would decrease then increase, and then go back down and up again in a cyclic manner. We then consider data from NASA regarding change in sea ice on the left video here and land ice on the right. over more recent years. It is crucial for students to grasp the patterns in these data as it motivates our work in a unit about how to slow the flow of energy to polar ice in order to decrease the rate of sea level rise. The next set of data is presented through three readings: Earth's orbit, year without summer, Earth's atmosphere. Through these three readings, we examine how these possible causes of factors, Earth's orbit and tilt, volcanic activity and solar activity, and atmospheric carbon dioxide concentration, affect global temperature. In part 7 of this lesson, we focus on how each of these factors affect energy flows into, between, and out of Earth systems. You may be wondering, why examine all these factors? Couldn't we just consider how atmospheric carbon dioxide concentration affects global temperature? These natural factors have been used as common objections to the scientific consensus of climate change caused by carbon dioxide emissions from human activity, such as burning fossil fuels. So it is important that we consider whether these natural causes are changing at the right time, the time scale of change, and in the right direction and rate, the proportion of change, to explain the recent rapid increase in global temperatures. For example, over the recent 30 years, solar activity, shown here in yellow, has been decreasing, while temperature, shown in red, has been increasing. So, solar activity is not changing in the right direction and cannot be the cause of the recent increases in global temperature. The final chunk in Lesson 2 is to begin developing energy transfer models to visualize how matter changes affect the flow of energy into, between, and out of Earth systems. For this type of model, we use rules such as drawing boxes to represent objects and arrows to represent energy flow from one object or system into another. At the end of lesson 2, we think about what we should do next to figure out how exactly carbon dioxide caused temperature to increase. We are trying to develop a mechanistic explanation about how this happens. Okay, let's talk a little bit about some strategies for this lesson. As I mentioned it before, it's important to draw out the cyclic patterns and the correlations between the three measurements of historical data: sea level, global temperature in blue, and the gray line represents ice volume. So I would suggest using a strategy like what I see and what I mean to guide student analysis. In this strategy, students first annotate the data with what they notice. For example, the blue temperature line has a downward slope, while the gray ice volume line has an upward slope. Then students go back and annotate what this means. As global temperature decrease, ice volume increase. That's the what I see and what it means strategy. The historical data would lead students to wonder how scientists collected this data. After all, first modern humans only appeared on the scene around 300,000 years ago, but we have data all the way back from 1.2 million years ago. So the readings in part 4 serves to answer students wondering. Now, students do not need to understand these collection methods in depth or detail, so I do not provide a hard copy of each reading to students. And I use a jigsaw strategy instead, where each student reads about one of the three methods: geological data, ice cores, and clues from humanity. And then they take turns sharing out in groups of 3, where within one group of 3, each student has read about one particular collection method. Since it is critical for students to digest how each factor, Earth's orbit and tilt, volcanic activity, solar activity, and atmospheric carbon dioxide concentration affect global temperatures, in part 7 and part 11, it's really those instances where you want to go slow to go fast, right? So give students the opportunity to wrestle with the data in small groups through the energy and matter chalk talk activity in part 7. Then the stability and change, construct, and argument activity in part 11. Subsequently, in part 12, the whole class will come together in a building understandings discussion to share their oral arguments. In order for students to practice with the rules for energy transfer models, I had success having students work in small groups to modify the base model on small whiteboards based on how they think a possible cause could change energy flow. So, across the classroom, we'll have at least two small groups work on one possible cause that gives them a way to compare and contrast how they modified the base model as well. Now, let's talk a little bit about poster management. In lesson one, the initial model is actually the first poster of the energy anchor chart. And then in lesson two, this lesson, we add the energy transfer model and students begin their progress tracker. We will be adding to both the energy anchor chart and progress tracker throughout the unit. Well, this is lesson two in a nutshell. Both science ideas and practices are a pretty heavy lift in this lesson, so be sure to give yourself and your students time and space for sense making. I hope you find this helpful and join us again for lesson 3, where students work together to collect data on the effect of carbon dioxide on temperature. Thank you.